welcome Piotr Mińkowski. He's a Java developer and software architect at Red Hat, enthusiast of the new technologies around Java microservices containers, and also has a blog, and he's also author of the book Mastering Spring Cloud. So, welcome, Piotr.
Hello.
Hi.
Hi.
Nice to see
Do
you.
you hear me?
Yeah,
Yes,
sure.
you too. Nice to meet you. Okay, so I can start, yes?
Yeah, sure.
Okay, hello everyone, welcome. Thank you for attending my presentation at the Cloud Builders Conference. Today we'll talk about tools and frameworks for Java development on Kubernetes and OpenShift. Before we start, some words about me. My name is Piotr Mińkowski. Currently, I'm working as a solution architect at Red Hat. Privately, I'm interested in Java, Kubernetes, microservices, cloud native development for years. I'm writing about it on my blog, piotrminkowski.com. The topics we'll cover today can be divided into two different groups. The first group contains tools dedicated for building container images. In the second, I'll describe CLI tools and platforms that automate the whole process of deploying and building and deploying applications on Kubernetes or OpenShift. And finally, we will talk about Kubernetes-friendly features provided by the most popular JVM frameworks in the third group. Why do we really need such tools? What is the motivation? We want to build a concept that is friendly not only for platform builders, but of course for developers. And typically, the process of building and deploying applications, and especially JVM applications on Kubernetes, can be divided in some phases. First, we need to build a binary with the application using preferred build tools. Then we have to build an image, push it to the remote registry, especially if you are working with a remote cluster, it might take some time. And finally, we need to deploy it on the target cluster. And if developers would have to repeat all these steps each time they want to deploy a new snapshot version to the cluster, it may be a really painful experience. We wanted to simplify a developer's life and speed up development process, yeah. So let's take a look how to do it. Starting from build images tools. Let's start from JIT. It's an open source tool maintained by Google, and it has been released in the stable version for the first time in 2018. It builds optimized Docker and OCI images with no need to maintain a Docker file. This tool is written in Java, and what is probably the most important, that it is dedicated only for JVM-based applications. And especially for the applications that are built using Maven or Gradle. You can also include JIT as a Java library, but obviously the most common usage would be as a plugin to those build tools. There are some interesting extensions created by the core JIT team, like GraalVM native image support, or support for the most popular JVM frameworks like Spring Boot or Quarkus. But probably the most useful features for you would be a built-in image layering and the ability to work without a Docker daemon. And JIT takes advantage of image layering and registry caching to achieve fast incremental builds. It is able to read your build config. For example, it can detect a version of Java application set in Maven configuration or Gradle configuration and assign a right image to the application. It divides your application into three different layers: dependencies, resources, and classes, and reveals and pushes only the layers that have been changed. And layering works even if your application is building a larger file, like with Spring Boot Maven plugin, for example. So Jeep can also handle it. And you can run Jeep in two different modes, and one of them does not require Docker daemon, as I mentioned before. It just builds the image and then pushes it to your image registry. Jeep can also be run in directly to a Docker, can build directly to a Docker daemon, your image, and this of course requires a Docker command line to enter your path. And that's how looks a typical minimal configuration of a Jeep Maven plugin. You just need to declare the name of the output image. The base image is automatically in this configuration set by the Jeep plugin. By default, it's a Google distro-less image. Of course, you can override the name of this image and use any other JDK image you need. You can customize many aspects of building container image, like setting environment variables, labels, or entry points. And many of the fields that are typically managed in Dockerfile. So Google is also is a tool for building images, but it can also be leveraged by other tools used for automating the entire development process on Kubernetes. We'll talk about these tools later, as I mentioned before. But now let's talk about another tool for building Docker and OCI images, Cloud Native Build Packs. Build Packs has been originally introduced by Heroku in 2011, and after that, Pivotal has also developed its own version of Build Packs. Finally, both these organizations started a project called Cloud Native Build Packs in 2018, and now it is part of Cloud Native Computing Foundation. The project aims to unify the build pack ecosystems to provide an abstract lifecycle. So in fact, it's just a sandbox project. So it's rather a definition than implementation. And how it works. So the main difference we've previously discussed Jeep is that it's a multi-language tool. So it's able to work not only Java application, and it requires a platform like Docker daemon to run. It's modular. Multiple build packs can be used to finally create an application image. And the basic concept behind build packs is to define a builder, which is the image that contains all the components necessary to run the build. Okay, so a builder image is created by taking a build image, adding lifecycle, build packs, files that configure different aspects of this building by including build pack detection or location of the run image. So each time you perform a build, you have a pair of related images stack. Yeah, so a build image and run image, and run image provides the base image for your application container. There is an interesting feature related to run image, by the way, rebasing. Rebase allows us to update only the run image. So if there is a newer version of the base image, rebase update just images layer metadata to reference to the latest version. You don't have to create new image of application once again. Build packs supports layer jars. There are multiple implementations of Cloud Native build packs available. For example, Spring Boot by default uses Okteto. You can also use Google Cloud and Heroku implementation, for example. And also multiple tools work with Cloud Native build packs. One of them is, for example, Pact. It's tool maintained by Cloud Native build packs project, and it supports, it allows you to perform a build using Cloud Native build packs. It's a CLI tool or a Go library. You can also integrate build packs with your CI/CD pipelines that are running on CircleCI or GitLab or Tekton. You can also use a keypack that provides a native Kubernetes native service to build on Kubernetes using a cloud native build packs. Okay, so let's take a look at the diagram that illustrates the build process with build packs. First, the platform starts a container from the builder image, and then it mounts the source code. During this process, a build image becomes an environment where build packs are executed, and a run image becomes the base for the final application image. And there are also life cycles. So we have 4 life cycles. In fact, first of them is detection, where build packs need to determine which build packs should be run for a type of depending on the type of application in order to run. So then there is analysis, build, and export. Okay, and we also talk about the next solution, OpenShift source to image. There are some similarities between source to image and build packs. If you think about it, there are both multiple language tools. They can detect a language from a source code and attach the right build image to it. And the source to image builder corresponds with the base image used for creating an application image. It produces ready to run images by injecting the source code, a star file into the builder image, and then builder image creates assembles a new image. And of course, source to image is a platform specific tool, so you can use it only on OpenShift. It uses a tool called Buildah for building OSI compliant images. It supports incremental builds with just reuse downloaded dependencies, build artifacts, and so on. Also, source to image is a part of larger concept or mechanism used for deploying your applications or OpenShift. And we can take a look at this process. So first of all, you can use OSI click command to create a new application on OpenShift directly from the source code. And in this case, this is a Git repository. It is possible to overwrite a base image. And what I'm doing in this command, so I'm using an OpenJDK 11 original 8 base image because my application is written in Java 11, for example. So when you create a new application, OpenShift creates a build config, image stream, and deployment objects for you. So those first 2 objects are specific OpenShift components. Build config describes a single build definition and a set of triggers when a build is created. So it may be triggered by a webhook, for example, from GitHub after the change in the source code. It's possible because build config is also exposed as a REST endpoint outside OpenShift cluster. You can also start the build directly using OSI start build command. And after the container image is successfully built, it's pushed into the repository, and deployment is able to automatically reload using the latest version of image. Okay, and that's all about built image tools. Now we can proceed to the CLI tools and platforms. So the first tools I wanted to show is Skaffold. It's an open source CLI tool from Google. It handles the entire workflow for building, pushing, and deploying your application on OpenShift. You can as well use it on OpenShift. You can easily integrate Skaffold with previously described build image solutions like Jeep or cloud native build packs, for example. Of course, you can still use Dockerfile, you can use Bazel, for example, a solution created by Google to build these ROS images. So you have many options, and the same is deploy phase. By default, Skaffold uses kubectl, but you can as well integrate it with Helm or Customize, for example. And Skaffold has many important features for Kubernetes native development, like policy-based image tagging, port forwarding, logging of running pods, file synchronization, and much more. And it optimizes your inner development loop to have an instant feedback while developing. Okay. It is also easy to debug applications with Skaffold, especially JVM-based applications. You can achieve it on a single command without any additional configuration. So you don't have to do anything else, just run this command. Okay, so let's take a look on the basic Skaffold commands. The idea behind Skaffold is to provide several commands for a particular operations. So for example, if you want to create a configuration for a new application, you need to run Skaffold init command. By default, this command creates configuration based on build from Docker file. So if you want to integrate it, for example, with Skaffold, we need to use enable jeep init parameter, exec enable jeep parameter on that command. And in fact, Skaffold init just creates a file scaffold yam in the root, in the project root directory. Okay, there are other project commands you see are used for development, so if you want to build and deploy our application once and finish the process, we need to execute Skaffold run command. Optionally, we can print the logs, and this command is finished. And if we want, for example, to delete resources and perform a cleanup, you need to execute the Skaffold delete. Okay, so it clears all the previously generated objects and artifacts. And the most commonly used command is Skaffold dev. It enables a local continuous development on your application, and while in dev mode, Skaffold will watch for application source files, and when it detects the changes, it will rebuild your images, push it to the registry, and redeploy your application, or it just will be able to synchronize the files with your containers, but it has to be configured properly for that. And the development loop will run until the user cancels the Skaffold process with Ctrl-C command. So after receiving the shutdown signal, Skaffold will automatically clean all artifacts and resources on the cluster. Okay, so the last command you can see here, Skaffold debug. It just acts like a Skaffold dev, but configures and prepares pods for debugging. So it's able to expose a debugging port outside the container and allow you to easily port forward this port. And especially for JVM applications, it exposes JDVP agent, which is a standard tool for debugging Java applications outside this container, so we can easily attach this debugger to the port, to the service. Okay, so let's see at typical Skaffold YAM configuration file. I just need to pass the output, the name of the output image. Okay, so but even in this example, you see that there are pretty many customizations we can use on Skaffold. For example, we can configure integration with Jeep. We can also pass some additional parameters, additional arguments to Jeep, like Maven profile that needs to be enabled during the build. Okay, so we can also switch between many profiles, and inside each profile, we can overwrite the whole configuration of scaffold phases. And in this dedicated configuration, you see that I'm creating a profile just for, with the name Knative, just for deploying all on Knative, instead of creating a standard deployment. You can also switch between multiple contexts, so in fact multiple clusters, or between namespaces on each command we are using for development. And something what may also convince you to use Skaffold is Cloud Code. It's an interesting option, especially if someone don't like command line tools. And why? Okay, first of all, Cloud Code tightly integrates with Skaffold. And under the hood, it uses Skaffold for deploying applications. And thanks to that, you can deploy the application just with a single click. So you see here on this slide that you have a single button. You also have a button for debugging. You can just debug the application with a single click. You don't have to even attach any debugger to it. You even don't know that it uses Skaffold, by the way. So Cloud Codes work with Google Cloud Shell, but maybe also installed as a plugin to IntelliJ and Visual Studio. And here is an example as a plugin with IntelliJ. So it also provides content assets for YAML files and even for Skaffold configuration. So we can also configure Skaffold using this content assets. Okay, next tool we'll discuss today is Tilt. How it differs from Skaffold. First, we are creating a configuration of build using a language called Starlark. This language is also used by Bazel for building images. And at the start, I think it may be a little bit too complicated in comparison to YAML, but since it is a language, it gives you flexibility, and you can define configurations more flexible than with YAML. So Tilt provides standard options also to simplify deployment, like in your development loop, port forwarding, change file synchronizations. And one of the interesting features is ability is extensions platform. So you can easily extend Tilt with a new functionality. So that's what I basically said. The Starlark language will help in it. But something what also differs it from Skaffold is a simple UI that may be run together with your build. So it allows you then, for example, you can take a look at the logs of each created pod using this UI. You can also put some other helpful information about the deployments. Finally, Tilt provides a cloud platform that helps you in team collaboration. You can publish snapshots with your image application and share it with your development team. And here you see a typical configuration of Tilt file that runs a single YAML deployment file in this way, this deployment YAML, and enables a port forwarding for your application at 8,000. Okay, so we also use Jeep as a build image tool by defining just a Maven command with Jeep Docker build execution here. And after creating this configuration file, you just need to run a tilt up command. And then you will be prompted to run it in interface UI mode, for example. And you see this UI at the bottom of the slide. So if you want to remove the resources, you have to run tilt down command. Okay, and Odo. Odo is a CLI tool for deploying on Kubernetes, but it is targeted to OpenShift, I think, because it provides some additional features when working with OpenShift, like, for example, integration with source to image mechanism. It also creating deployment configurations, build configurations, roles, for example, typical elements of OpenShift. And the main concept with Odo is pretty similar than a concept across OpenShift. So it does not require a deep understanding of Kubernetes platform and hides this complexity against the developer, in fact. So it defines a specific developer-oriented model, which consists of application, and this application will contain multiple components and services. Usually, maybe only one component. But component is typically related to, for example, a single microservice that can be run and deployed separately. A service is some kind of a software like database, for example, which is used by your component. Okay, so Odo supports multiple languages, may work in two different modes. It's dev file and source to image. So source to image is related with OpenShift. Well, it detects also changes in your source code and is able to automatically deploy it on the cluster. You may also easily debug your Java applications using the same mechanism that, in fact, is in Skaffold's or JVP protocol. And the idea behind Odo commands is pretty similar to Skaffold. We have several commands per each operation. We can create, for example, a new component locally using Odo create command, where we need to set the type of component like Java and the name of its component like sample app, for example. And once we create it, we need to push it to the cluster. Just with Odo push command, we can optionally print the logs from this build. And to create an inner development loop and watching for the changes in file, we need to run Odo watch command. You can also easily debug our applications with Odo debug command. We need to set up a port for value in this case. And finally, we can verify a list of our web components to deploy on the cluster with Odo catalog list components. And on the right side of the slide, you see the result of these components. We have several components for dev file mode. These are typically related to the frameworks, for example, we use, and we can also choose between several S2E components. And on the left side, you see a configuration of Odo. It's created in the Odo catalog after running it on application. Okay, and the next tool I wanted to discuss is Okteto. Okteto is a platform on Kubernetes dedicated to developers. And it may be used in two different modes, as a hosted solution and as an enterprise solution. So it is important that it is a platform, not a CLI tool only. So for a simple individual development, it may be used for free. It's also an enterprise version. It's free to try. So you can install it on an existing cluster with Handchart. But what is exactly Okteto? I'll describe the hosted solution. So you as a developer, after login, receive an individual secure namespace on Kubernetes. And you can easily manage it using Okteto UI web console. For example, run a popular software like databases or message broker, which are used by your application just with a single click in this UI. Of course, you also need to install CLI on your device. And all the magic happens when you run Okteto app command. It's quite similar to Tilt, in fact, but you need to run it, of course, inside your source code. And before that, you need to log into the cluster using the right command of Okteto CLI and create a configuration in YAML notation. I will show this configuration then, but Okteto also gives your team a self-service to access Kubernetes cluster. It can also apply security policies. It is able to sleep idle resources, or just clean up unused namespaces. It also allows to debug applications easily. How it works for a typical Java application. So Okteto CLI is connecting you to the remote cluster. It allows you to edit the files like in normal local development. But when you change the file, this change is pushed to the remote cluster automatically. This process is transparent for you. And look at the configuration file. You see that there is an Okteto Maven image used. So it starts our Spring Boot application using Maven command, nvn Spring Boot run. It's typical command exposed by Spring Boot Maven plugin. So it does some magic like port forwarding. It also allows file synchronization. And finally, you should include a Spring Boot DevTools to the application that allows you to automatically reload your application after change. And that's how Okteto handles a change of your application for Spring Boot. Okay, and last topic in this section, Knative. Of course, it's a framework, it's a platform to build and deploy serverless workloads. But what is important for us is developer-friendly software. So it does not, it may do some things like takes care of details of networking, of the scaling, revision tracking, for example, and thanks to that, developers can focus on the core logic. So developers can also use a language framework or idiom they are familiar with. And what is important, you can run any type of application on Knative, not just a function. Okay, so you can also take an advantage of Knative eventing model. For example, it's universal subscription and management of events, especially cloud event specification. But you just need to attach your application to the stream of events, and you don't have to do anything else to deploy it, just to expose, for example, a single REST endpoint that is called by this model. And we can use Knative CLI to run applications on Knative serving. And Knative takes care of everything else, like creating a revision after deployment or exposing a service using root object. So we can also easily split traffic across multiple previous revisions, and Knative is able to store all these revisions. Okay, so a last part of our presentation, JVM frameworks. Let's start from Quarkus. It's Kubernetes native framework. It's built on top of microprofile and Vertex. What does it mean? It is a Kubernetes native framework. For example, if you compare it to the other frameworks like Spring Cloud or Micronaut, it does not provide any built-in integration with external discovery servers. But instead, it offers several simplifications that speed up your development on Kubernetes or OpenShift. What are these simplifications? We will talk in the next slide. But Quarkus is tailored for running with GraalVM. Native images is optimized for low memory footprint, fast startup time, and these are all things required by microservices or even more by serverless applications. Yes. So Quarkus provides several extensions for Kubernetes, Knative, or OpenShift. One of them is an extension for building container images with zip and source to image. For both these tools, it offers a dedicated base image to be used when a container image is produced, and even for a native binary build, dedicated images for native binary builds. And Quarkus offers an ability to automatically generate Kubernetes resources based on the source code or user configuration application properties or annotations in the source code, for example. So after creating such manifest, you can automatically deploy your Quarkus application on Kubernetes or OpenShift on the cluster using a single Maven command. And by design, Quarkus exposed the health checks dedicated to the liveness and readiness probes. So typically set that are typically set for deployment on Kubernetes. It also includes Kubernetes config extension, which allows you to use config maps or secret as a property sources without having to deploy them as a mounted volume or defining a reference in deployment manifest. And there is also interesting module Funky with functions implementation for serverless. Thanks to that, we can very easily integrate Quarkus even with a Knative model, Knative eventing model. Here's an example configuration of a Quarkus Kubernetes model. So it's our application YAML. We have several properties. First, if you set a Kubernetes deploy, Quarkus Kubernetes deploy property, it will be automatically deployed to the cluster during the build. We also should set a name of the target platform, especially if it's different than Kubernetes. So in this case, it's OpenShift. And all other properties with Quarkus OpenShift prefix are responsible for generating our deployment manifest. So we expose our service outside cluster via the root object, for example. We are running 2 pods of our application, so we may set some labels or annotations, even annotation responsible for including our application to the service mesh, like in this example. And finally, we can setting a reference to the existing secret, for example, to inject database credentials or database name. You just need to use the name of the secret and name of a key inside it. So then you can just deploy it with a single command, and if application is deployed, you can then provide a deployment, continued deployment with Quarkus remote dev command also. Okay, some time ago, Spring Boot or Spring Cloud didn't provide many significant features for Kubernetes or even containers, but things have changed. Currently, you can even run Spring Cloud Gateway on Kubernetes with custom resource definition very easily. In the last 2 versions of Spring Boot, so 2.3 and 2.4, Spring team has other several improvements dedicated for containers and Kubernetes, and one of them is support for liveness and readiness probes in Spring Boot Actuator. We can enable it in configuration properties. We can include a list of components that should be exposed in such probe. For example, we may include the database component to the readiness check. There is also a graceful shutdown available, which is important when running applications inside the containers. And there is also a built-in support for creating images with Cloud Native build packs provided by Spring Boot Maven plugin and Spring Boot Cradle plugin. We can build the image just using a single Maven command, Spring Boot build image go. And Spring team is also actively working on Spring Native project that improves the support for building native images. And some days ago, they announced a beta version with several significant improvements in this area. And of course, there is also a Spring Cloud Kubernetes project with a dedicated integration with Kubernetes between Spring Boot and Kubernetes. So Spring Cloud Kubernetes has been originally created and maintained by Fabric IDEs, and it was moved to the Spring Cloud incubation stage. Currently, it's a third, the most popular Spring Cloud project when looking at the number of GitHub stars. So it allows us to, for example, to use config map or secret as a property source for Spring Boot application. We can also take advantage of the auto reload mechanism, where Spring Cloud Kubernetes watches for changes in the config map or secret. We can integrate with Kubernetes Discovery, for example, and there is an implementation of abstract discovery client. It's a basic object for integration with discovering in Spring Cloud, and we can create a dedicated. We have a dedicated implementation of this discovery client for Kubernetes API. And thanks to that, we can, for example, easily integrate HTTP client and HTTP client and load balancer to communicate directly with the pods instead of using Kubernetes services. And we also have an advanced health check with detailed information about the pods. So here is how it looks a typical implementation of this injecting config map into the application. So we just need to set a proper name of a config map in a metadata name field. It should be the same as the name of Spring application in the Bootstrap YAM file. So in this case, it's department. And as you see, config map defines a content of application YAM file. And when our application starts, it just find this config map and use a configuration defined in it using application YAM. And you can also easily use a high-level HTTP declarative client like OpenFail, for example, just to communicate with the application pods using the name of application, thanks to this integration with Kubernetes API. Of course, our application needs additional rights, privileges to be able to communicate with Kubernetes API. And the last point of our presentation, Micronaut. Micronaut is a very interesting framework, in fact, also dedicated for microservices and serverless architecture. It is optimized for a minimal memory footprint, fast startup. Right? What is interesting is written basically from the beginning, so it does not use many third-party libraries, or if we even use any. One of the example of such implementation is a custom implementation of Kubernetes client. For example, Spring Cloud and Quarkus uses a Kubernetes client implementation for Fabric IDEs. So Micronaut Kubernetes module gives you a similar integrations than Spring Cloud Kubernetes. You can integrate with service discovery. You can use config map as a property source. You have advanced health check. You also can use config map and secret as a mounted volume and provide some additional service filtering. And also, let's see how it looks typical in integration with config map. This process is a little more flexible than from Spring Cloud Kubernetes because it's based on the labels. So we may define multiple labels, and then our application is able to match multiple config maps based on these values of these labels. And the same as for Spring Cloud, we can also use integration with Kubernetes Discovery, so we may communicate directly to pods using the name of service, the name of application, in this case employee. Okay, and in fact, it's all what I wanted to say today it's not everything, because there are also some interesting tools that we can use for development. We didn't say anything about tools for automated tests. We also could say a little bit more about tools like Decorate, for example, using by Quarkus to generate the manifest from source code. There's also JCube, for example, that allows you to generate manifests. It's a Maven plugin from Maven configuration. There are also some similar tools like Skaffold, for example, Draft or Garden, but I wanted to focus on the tools I use privately. So I hope you enjoyed this presentation. Thank you for your attention. If you have any questions, I will answer now with pleasure. But if you also have questions after this presentation, you may find me at Twitter, and you can send an email. So thank you once again, and I'm waiting for your questions.
Yeah, thank you very much, Piotr. It's a really, really great article, and also I think I also have some notes, yeah, for the Kubernetes. Yeah. So yeah, we have questions. The first one is build packs vendor locked, or I can use multiple build packs? Is it any probably choose?
You are asking about an implementation of build packs?
Yeah, it's probably more about how I use build pack, probably. Yeah, in something like Cloud Foundry or something like that, different build packs. Is it compatible, or it's only vendor locks, something like that?
No, of course, there is no vendor lock. It is cloud native build packs is some kind of abstraction. So we've got similar. We've got some implementations, like for example Okteto, which is used by Spring Boot, but you can as well use it to build another applications. Yeah, so it's just the case to use. To choose implementation of a builder image and a pair of it's related with run image. Yes, so of course I said a little bit more about it, that you can also easily run such a build on Kubernetes with Keypack. You can also integrate it with some CI/CD tools like Tekton. So it gives you many possibilities to integrate it with your application.
Yeah, great. I think yeah, have an answer. Yeah, so thank you, Piotr, for this really great article. So it's for me, it's really, I really enjoy it. Yeah.
Thank you.
So then have a good day. Thank you very much.
Thank you very much. Bye.
Bye.